Hello guys, welcome back to our channel. Today we are going to see about what is a 7 segment display, what are the types in the 7 segment display and how to make the Verilog code for that. On going to the topic of the 7 segment display, there are two type of displays are present in the 7 segment display. One is a common anode and other is the common cathode. The major difference in the common anode and the common cathode is nothing but if you are operating a common anode display, then you have to pass the logic 1 or high voltage to switch on the LEDs. In the common cathode, the process will be reversed. You have to pass the logic 0 or low voltage to on the display. Now we are going to discuss today in this video is common anode display. Okay, so in the common anode display, how many segments are there? 7 segments, right? So 1 2 3 4 5 6 7, right? So I am writing this A B, C, D, E, F and G. So now I will write here how many possible combination will become from 0 to 9. So 0 to 9. So how many bits will be required? 2 power 4 bits will be required. 2 power 4 means we will get 16 and 2 power 3 means we will get 8 bits, right? So we require here 4 bits up to 9. The possible combinations are there, so we will take the 4 bits. So what will be the 4 bits? I am taking as A B C D 0 0 0 0, or you can take as A B C D. Okay, we have 16 possible combinations are there, right? So these are the all 9 possible combinations we require. Other possible combinations are not required for us because we have the sequences from 0 to 9 only, right? So I am write the 0 to 9 only sequences. So what are the segments available? A, B, C, D, E, F, G. So in this video we are discussing about the common anode type. So we have to pass the logic 1 to get the output. So for logic for 0, how many segments are have to active? A, B, C, D, E, F, and G should be inactive like A, B, C, D, E, F, right? A, B, C, D, E, F, and G is not required. So we have to pass the one for all logic ones to the all segments except 0. I mean 0. So we in the common cathode it will be reversed. We have to give all the logic zeros to the segments except Z. Okay, in this way this common anode truth table will be generated. So for logic 1, BC will be logic I. Here write 0 1 2 3 4 5 6 7 8 9. For logic 2, for 2 what we have to run? A B G E D, right? A B G E D and remaining all zeros. In this way write all the ones and the zeros for the remaining logics. So this is the truth table for the 7 segment display of common anode type. Now let's make the Verilog code to verify this functionality. Okay guys, now let's see how to make the Verilog code for the 7 segment display. Okay, for that we have to create the module with the name called, I am giving just as 7. We require an input, but I am taking as a BCD, which is a range between it is 4 bit side, so 3 is to 0. And I'm closing this, and we have to take the output segment, and this range should be 7 segments, right? So 6 is to 0. Okay, so these are the inputs and the outputs, and here we have to particularly mention the resistor because we are using the behavioral modeling approach. In this, the output will be stored in some resistor, and we closed this module. Now we have to assign it, so always at the rate BCD, because according to the BCD input we have to give the output, right? So I'm taking the always at the rate BCD, always at the rate BCD, and begin. Now I will use the case statement, case BCD. So if input is 0, then what will be the output? 7B 1 1 1 2 1. We 7 segments, right? So all the 6 segments will be 0, and last one is a 0. Okay. Now for 1, and we are giving the segment, and segment, because segment is nothing but output, right? So for 1, what will be the bits we have to on according to our design truth table? 0 1 1 0 0 0 0. Yes. Now for 2, same segment equal to 7b double 1 0 double 1 0 1. Next 3. In this way, we have to give all the segments values, so that when the BCD input is came, according to that, the output will be produced at the. We can see this output at the monitor. Triple double one double one double zero one 4 segment equal to 7b 0 double one double zero double one 5 is equal to segment 7b. So these are the all the segments, I mean these are the all the statements. Now I'm closing this statement called end case, and I'm closing it the end, and I'm closing it and module. Okay, so this is the design code for our 7 segment display. Now let's write the test bench code to verify this functionality. So for that I'm creating the module tb. What are the inputs is nothing but the register, right? So register 3 is to 0 bcd, and we require the wire 6 is to 0, output is segment. Now I writing the extracting the all the inputs and the output from the main module 771. Here what are the required bcd comma segment. I'm closing this. Now I am going to start giving the test bench initial, and before that I will consider another integer I, which will be used for our for loop. I am giving the test bench for the module. So initial begin $monitor is used to display the commands and the outputs and the inputs at the display. So input to bcd is equal to percentage b. Now bcd is equal to percentage b, which is one input, and the another output segment, right? Segment percentage b. I'm closing this b. Now bcd comma segment. So these are the inputs and the outputs. Now we will start giving the loop for I equal to 0. We will 15 and 16 I plus plus. Now these input will be given to the bcd equal to I. Okay, I'm giving some time delay $10. Now I'm closing this and module. Okay, this is the test bench code for our 7 segment display. Now I'm selecting the some tool, and I will show you the output. Saving this file, and I'm going to run this. I'm giving a name called 7 segment display. Okay, now I'm saving this, and I'm going to run this. Yes, here there are some errors in the testbench.sv.11 is here. Here we have to give some command called begin. I'm again saving this, and I will run this. And again there is some error in this line only. Yes, here there is some error called sv.11, right? Here we have to give the syntax like I equal to I plus 1. Okay, this syntax only work in this Verilog. Now I am saving this file, and I will run this. Now I think there will be no errors in the code. Yes, the desired output is come. If the input is 0 0 0, the output is all ones except the Gmod. So in this way we can design the 7 segment display using the Verilog. Thank you for watching this video. If you have any doubts, please mention in the comment section. You can get the code through the GitHub, which is provided in the description. And thank you. Stay tuned for the next video.